So now we're in our next chapter. It's called Coordinate Geometry, and we're going to practice how to plot points, graph lines, write equations of lines. And this is a big topic that will help get you prepared for Algebra 2, because linear equations is what comes up in that class. Okay, so this is an XY coordinate plane, and many of you have probably seen this before, but we have axes. Our x-axis is always horizontal. And our y-axis is our vertical axis. Okay, so our y-axis is here, x-axis is horizontal. And then we have the origin. And the origin is where these two axes intersect. And the coordinate point for the origin is 0, 0. Then we have things called quadrants. We have 4 of them. And it sounds it's different. So we look at our XY coordinate plane, and we have coordinate 1, coordinate 2, coordinate 3, and coordinate 4, or quadrant 4, excuse me. So quadrant 1, 2, 3, and 4, and they're written in Roman numerals. So the reason why quadrant 1 is over here is because when we plot points, let's say I pick this point, both your x and your y coordinate points are positive. So how do we find this point? We go over 1, 2, 3, 4 in our x and up 1, 2, 3. So this point is 4, 3. So if I asked you to plot a point -5, 4, coordinate points are in the form x, y. So you move horizontally and then vertically. So to plot -5, 4, I'd start at my origin and go over 1, 2, 3, 4, 5, and then go +4. So up 1, 2, 3, 4. And this is -5, 4. And then if we wanted to plot in the third quadrant, we would have a negative and a negative. So if I had -8, -3, that's that point. Or I can say +1, -5. That's where that point would be located. Okay, so points are also labeled by capital letters. But if we wanted to find the distance between 5, 7 and -1, 7, we have to plot those points. So let's start. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, and then also -1, 7. And if we drew a line in between those, we want to find the distance of that line. And since it's a horizontal line, can't we just count? So starting from here, going 1, 2, 3, 4, 5, 6. So the distance between those 2 points is 6 units. So this would be point A, and this would be point B. All right, let's look at number 2. We wanted to find the distance between those 2 points. So 4, 2, -2, 1, 2, 3, 4, down 2, that's point C, and then 1, 2. So this point, or this line, it's not as easy to find the distance between those 2 points because it's on a slant. So what we can do, we can use our knowledge of triangles to help us. So what if we created a right triangle here? We could find the distance between C and this point, so 1, 2, 3, and then the distance here, so 1, 2, 3, 4. So if this is 3 and this length is 4, the length of DC would be 5. Because of our Pythagorean theorem. So if we think about this, let's call this point X, okay? So what it is that we're trying to do, we're trying to find the difference between our X coordinates. Okay, so if I did 4 minus 1, I end up with 3. That's how we got this 3 here. Okay, and then if I did my my y coordinates, -2 minus 2. I got -4. Okay, so if we're looking at that, okay, we have -4, but if we think about the distance, we have to take the positive. So if we think of a squared plus b squared equals c squared, our a squared would be this 3 squared. Our b squared would be this -4 squared, or we could just say 4 squared. And then we could find out what our c squared is and solve using the Pythagorean theorem. So there's an easier way. It's called the distance formula, but the distance formula comes from the Pythagorean theorem. So if we're looking at this particular problem, here's the distance formula. All right, if we want to find this length, we would have to subtract our y values because we're going down. So 1, 2, 3, 4, 5, 6. Another way to do that is to do subtracting our y's. And then here, if I wanted to find the distance between P and R, that way we were counting our x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the distance formula is saying we could take this length, square it, this length, and square it, and then we can use the Pythagorean theorem. Okay, let's call that our B, and this our A, and this our C. So to find our A, we had to take our x values, so x2 minus x1, right? And then I'm just plugging that in here. So we knew that this number was 9. Okay. And then here, when we found our B, we had to subtract our y values. And then we're just left with c squared. But in order to find c or solve for c, we could take the square root of both sides. So the distance formula is the square root of x2 minus x1 squared, and then y2 minus y1 squared. So this is a formula that we're going to be using, and we have to think about PEMDAS when we simplify. Okay, so we have to work inside of those underneath that radical, and then at the final step, take the square root. So let's go through an example. I like labeling my points. So x1, y1, x2, y2. It's just a way to denote our points. And our distance formula is x2 minus x1 squared plus y2 minus y1 squared. So x1 minus x2, 9 minus 1 squared. And then -4 minus -8 squared. Okay, so we can say 8 squared plus 4 squared. Remember, that's all under the radical, and we have to simplify this first. So we have 64 plus 16, and we end up with 80. So we're taking the square root of 80, which is the same thing as 16 times 5. So we got 4 root 5. So that's the distance between those 2 points. So you have to always simplify under that radical first. Okay, and then take the square root at the end. So that's going to be super important with these examples. Okay, so next thing we have is the midpoint. So midpoint, we've looked at midpoints before, and if we had a midpoint, we have a segment, and if we had a midpoint, that's showing that these two pieces are congruent. So we have to find the exact middle. So here we are, 1, 2, 3, 4, 5, 6, 7, 8 is the distance of AB. So 1, 2, 3, 4, this is our midpoint of AB. Okay. And then also with CD, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that means halfway, 1, 2, 3, 4, 5, this is the midpoint. But then again, we have something on a slant. And if we wanted to find the midpoint, what we have to do is average the coordinates. So E is -7, 2. And F is -3, -3. So if I'm averaging, I have to say -7 plus -3 divided by 2. That gives me -5. And then I have 2 and -3. So 2 plus -3 over 2 gives us -1/2. So that means at -5, -1/2, we have our midpoint. So let's see, 1, 2, 3, 4, 5, -1/2 is our midpoint. So this is the midpoint formula. If we take our x values, average them, so add them, divide by 2, take your y values, add them, divide by 2, we're averaging the x and y points. So if we want to find the midpoint of the segment joined by these coordinate points on the bottom, what we can do is say, all right, well, what's -11 plus 8 over 2? And then what's 3 plus -7 over 2? And so here I get -3 over 2, and then here I get -4 over 2, which is -2. So we know that this is the midpoint. So having these formulas are going to be useful in finding the distance between the two, and then also the midpoints.